So with these questions here, guys, what we want to first understand is this m over 6, that can be written a couple different ways. Okay? So I'm just going to come to the side here and just display the different ways that you might see this written. And when there's situations throughout the entire curriculum in which we can maybe talk about an algebraic expression written this way or an alternative way, I'm going to show you and try to use all the different routes and ways it can be written, because my fear is that we get to the end of course exam, and if I only use m over 6 and they use on the test a different version of that, because you've never seen that different version, you're not going to be successful with that question. Does that make sense? Okay. So I just want to make sure that we're able to kind of jump back and forth between different formats of writing, for instance, this case, m over 6. And hopefully demonstrate at the same time the algebra that allows that. Would you guys agree that m times 1 is still m? Would you agree that 6 times 1 is still 6? Okay. If I have, just based on what we know about fractions, like if I had 2/3 times 4/5, we could rewrite that as 2 times 3 over 4 times 5, right? Okay. We can merge that into one fraction and just do the operation, the multiplication up top. That's what we've got going on here. But right here, I'm going to start with the 1 over m and the 6 over 1. I'm going to start on this side and try to break it apart like that. Does it make sense then that I could rewrite this as 1 over 6 times m over 1? Does that make sense to everybody? Okay. So now what's m over 1 the same as? Just m, right? If I gave you 5 over 1, you just write that as 5. If I give you 12 over 1, you should write that as 12, right? So m is just m. So now, wouldn't you agree that this is 1/6 times m that way? Does that make sense to everybody? So when you see something like that, you can rewrite it that way. So if I have like a over 12, you can rewrite that as 1/12 times a. If I see a over 31, I can rewrite that as 1 over 31 times a. Does that kind of make sense? And you're going to see me from time to time jump in and out of these two formats. But if I look at this first question that we're doing, and I write this as 26 is equal to, now I rewrite this as maybe 1/6 m plus 5. I think writing it that way might help us realize what we're supposed to do in our last step. Okay? The first thing I want to do, so this is a two-step equation, the first thing I want to do is look at that thing that is non-variable, right? We call 5 a constant. So m is going to be our variable, right? And just kind of maybe talk about this terminology real quick. That's a variable because if m is 6, that thing turns into 1, right? If m is 12, that thing turns into 2. If m is 24, that thing turns into 4, right? Whatever m is, that thing I highlighted changes. But 5 never changes, right? And things that never change are said to be constant. Okay? If the temperature was constant, it would be 70 degrees all the time. Okay? Or whatever temperature all the time. It would never fluctuate. Okay? So this is referred to as a constant. What we want to be able to do is look in the two-step equation is make all our constants, okay, that are on the side of our variable go to 0. We want them to just disappear, vanish. Okay? But we have to use our inverse operations to do that. So if I want positive 5 to vanish, meaning I want it to go to 0, what do I need to do first then? Lindsay? Subtract 5, right? So let's subtract 5 here. If I do that to the right-hand side, what do I have to do to the left-hand side? Same thing. Okay? So that is exactly the same step that we conducted yesterday on the 4 or 5 examples we did yesterday. Now, people see the 21 equals 1/6 m, and they think, okay, 1 over 6 times m. Well, those two things are stuck together through multiplication, and I agree 100% with you that they are. And they say, well, let's undo multiplication with division and divide both sides by 1/6. Absolutely correct. It works. But when you divide by 1/6, Whenever you divide by a fraction, the actual math you go through to do that is you multiply by the reciprocal. So let's just do that at the onset. Does that make sense? Let's eliminate a step, and let's just say right here, and this is why I like to write it as 1/6, because you automatically can see what the reciprocal is, right? And the reciprocal is just that fraction flipped upside down. So I'll multiply this side by 1, or 6/1. So that's going to give me just 6/6m, which we know to be 1m, right? Is that okay with everybody? All right. A lot of times, I mean, you can write this if you want to, and then write that is equal to 1m, and write down like that step. You don't have to, though. If we understand that we're choosing this conveniently, we have intelligent thought behind this, we know every time that we do it correctly, it should be 1m down here. But if I multiply the right by 6, what do I multiply the left by? 6. Okay? And then, so 21 times 6 is 126. Okay? Now, like every other equation, and this is, guys, this is a fact across all of algebra. No matter what level of algebra you're talking about, 1, 2, 3, 4, whatever. When you get an answer, you should always be able to plug that answer back into the original and see if you get a true statement. So what I'm going to do is plug that back in right there. I'm going to put 126. Okay? Now, that right-hand side now turns into an order of operations question, right? We've got division and we got addition. Which one do you have to do first? Division. So you got 126/6. Well, we just did the multiplication that got me 126. That multiplication included 6, right? So if we did that right, that number, that 126/6 should be 21, right? What's 21 plus 5? 26, which is the left-hand side of the equation, right? Every single equation has a built-in check to it if we plug back in and go through the order of operations. Yes. Yep. So another way that you guys are going to see maybe it's nothing different. It's just the way, and that's what a lot of questions people will ask is, if I did it this way, is that okay? The logic that you use when you do something a little bit differently than what I do and get the same answer is the exact same logic. It's just the way you present it might look a little bit different. So Lindsay's question was this: if I have 26 is equal to m/6 plus 5, she subtracted 5, got 21, equals m/6. She multiplied like this and canceled, right? Okay. And then came over here and multiplied by 6 and got 126 equals m. This cancels because of this idea. I multiply that by 6/1, and I get 6m/6. And 6m/6, that's still my 1m, right? So that's perfectly fine to write it that way. I like writing it that way. You're going to see a lot of times, if you were to see a textbook demonstrating questions, their worked out processes are probably going to incorporate something that looks like that. So yes, that's fine. If we do this next one, y over 5 plus 2 equals -8. Y over 5 plus 2 equals -8. What do you want to do first? Boston? Subtract 2. Okay. Subtract 2. Minus 2. Minus 2. Okay, we want, because the variable part needs to stay put, right? And we'll get y over 5 then is equal to -10. -8 minus 2 is -10. Okay? What's that? Yep. Yep. So now I've got this 1/5 that's showing up here as my coefficient. So Devin's saying multiply by 5/1. Come over here, I'm going to multiply by 5/1. Okay, if we're using the canceling idea, those would cancel. It would be 5/5. Gives me 1y. And what's -10 times 5 then? -50. And if you plug it back in, take -50 divided by 5. What's that give you? -10. Add 2 to it. gives you your -8, right? Okay. Once we get a little bit more kind of polished with our properties here and our processes, I will show you how to use the end of course exam calculator, Desmos, on how you can check yourself with that a lot quicker. Okay, but I want us to check ourselves right now using order of operations because it's going to get us more practice at that. Okay, we need more practice with order of operations. All right, so you guys take a minute, see what you can come up with on the next two. Do those next two on your own. I'm going to write a couple additional to this, so while you're doing that, I'll write them, and we'll reconvene. All right, so what do we do on this first one? A over 5 minus 18 equals 2. Add 18, good. Add 18, so that's going to make that go to 0. That's going to dissolve that, okay? And there we go. Then we're going to add 18 to this side. So A over 5 equal to 20, right? Now what are you going to do? Multiply by 5 over 1. 5 over 1. 5 over 1. Cancel, cancel, leaves me just A. What we're really doing over here, and that's going to make a point that we kind of glaze over a lot of times. When I'm multiplying two whole numbers like this, they're over 1, right? So when I'm multiplying, I am taking 20 times 5, giving me 100. And then 1 times 1 gives me 1. But usually people they ignore that because they know it's going to be a 1 on the bottom, right? I think that's important to talk about for the fact of the two additional questions that I wrote here in a moment are going to incorporate us to understand that idea. Okay? But is that okay? Everybody get 100 on that? Okay. Looking at this one, and this is the thing I told the last class. You guys can do anything you want to do to these equations. Everything I try to teach you is going to be kind of an efficiency thing. Okay. If I had tools to rake a yard, okay, rake the leaves up in a yard, and I was trying to show you, because maybe you lived on a different planet and you've never raked a yard before, that I have a lawnmower, a push lawnmower, a riding lawnmower, or I've got a leaf rake, and I was trying to show you the best way to mow or to rake that lawn. What tool would I use probably to do that? That would be most efficient. I'd use the lawnmower, right? Because it's gonna chop the leaves up and it's gonna blow them into piles, right? Now I can use the push mower, which is gonna be better than the rake, right? Or I'm gonna use the riding mower is gonna be the most efficient, correct? Does that make sense? So that's the idea. Whenever we're doing an equation and we walk through a process, we walk through steps, I'm trying to teach you the most effective, the most efficient. Because there's an infinite number of ways of doing this. Okay, think about this. Could I subtract 5 here? As long as I subtract 5 there? Now think about this. That would give me 5 plus h over 3 equals -4, right? Well, let's subtract 5 again. Does that give me h over 3 equals -9? Now would you multiply both sides by? 3 over 1. 3 over 1. So that'd give me h to be -27, right? Did I get the answer?
No. Wait, after you did it all?
H is -27, right? Let me go back, because I subtracted 5, and then I subtracted 5 again, right? Some of you maybe subtract 3, and then subtract 7, but those are inefficient, right? What's the best thing to do? Subtract 10, right? Subtract 10. And now I get h over 3 is equal to -9. Now what can I multiply everything by? 3 over 1, 3 over 1. And that gives me h equals -27. A different route, same answer, right? But the goal, remember, is to get the h over 3 isolated. And whether I do that in one step by subtracting 10 one time, or I do it in 2 steps by subtracting 5 and then 5 again, it is obviously your option, but hopefully everybody subtracts 10. Now, there is another thing you can do. Okay? And maybe we've talked about this before in other classes. You guys know what a LCD is? A least common denominator?
Yeah.
Okay. So basically what we do is we make sure that all our denominators are factored. Okay, and this, I'm not going to talk too much right now about how to factor them. But basically what we do is we look at all the, I don't know what happened. Hold on a second. What in the world? Okay. Basically what we're going to do is we're going to look at all of our denominators and see what is the smallest thing we can kind of make them all. Okay, and can I make them through multiplication? Can I make them all 3? Does that make sense? Okay. So what I'm going to do is I'm going to multiply. I see that the LCD is 3, so the idea is to multiply every one of these things by 3. And this will be a process that we talk about in a lot more detail later on. But what's 3 times 10? 30 plus, now this is 1/3 h times 3, right? If you add 1/3 h times 3, that means you have 1/3 h plus 1/3 h plus 1/3 h, right? How many h's would you really have? If I had 1/3 of an h, 1/3 of a piece of pie, plus 1/3, or 1/3 of pi, plus 1/3 of pi, plus 1/3 of pi. If I had 3/3 of a pie, that's what this is saying, right? I'd have a whole pie, correct? So when I multiply h over 3 times 3, this gives me h. And now 1 times 3 gives me 3, right? How can I isolate this h right here? Subtract 30. Does that still give me negative 27? Does that make sense? That's an approach, and like I said, we're going to talk about it a lot more later on. That's an approach that a lot of people become accustomed to and they start to preference because it gets rid of fractions at the onset, right away. Okay? But we'll have to have that discussion on how do I choose a least common denominator and all that kind of stuff. But what I want you to see is that there are different techniques for solving an equation. There's an infinite number of ways you can do it as long as you do it to both sides. There I multiplied both sides by 3. Okay? It's perfectly fine. Then I subtracted 30 from both sides. All right? A lot of algebra, early on we learned how to solve the equations, and then as we move through other concepts, we learn little kind of twists and turns and tricks that allow us to maybe solve them quicker or easier or in additional forms. Okay? So this one here, I want to do this 2/3 x minus 4 equals 8. This is different than what we've been seeing because everything we've seen so far, the ones that I have printed out for you, it was like a over 5 or m over 6, right? The coefficient was a 1 over some number. 1 over 5, 1 over 6, 1 over 3. Here, it's a 2 over 3. Okay? Now, you can write this. You don't see this very often. You can write this as 2x over 3 like that. That is the same thing as 2/3 times x. Okay? So, I'm going to write it on the right there, like the 2/3, and then the x afterwards. But some text, I don't know, math itself for the most part writes it that way, but occasionally you might see the x put up in that numerator. It means the same thing, okay? And the reason it means the same thing is, remember, this is just representing a number, right? And it's a number over 1, right? And this essentially tells me I'm multiplying 2 fractions. That means I can multiply the top numerators, 2 and x, and I can multiply the bottom, 3 and 1. So that is the same thing as kind of that. Does that make sense, everybody? Okay. When we see questions like this, guys, nothing changes. Nothing at all changes. Even though it looks a little bit different from the way we started, the process is the same. You're going to look at your variable term, and you're going to keep that where it's at. And I'm going to try to get all the things that are on that side to go to 0. So I'm going to add 4 to this one. I'm going to add 4 to that one, right? So now I get 2/3 x equals 12. Okay? Now think about all the examples that we did. Okay, now don't tell me specifics. Don't tell me I multiplied by 6 or I multiplied by 3 or I multiplied by 5. You multiplied by the what? The reciprocal of the coefficient, right? You multiplied by the reciprocal of the coefficient. That's the same thing we're doing here. But what's our coefficient? Careful. Okay. 2/3. So 2/3 is the coefficient. What's that reciprocal? 3/2, right? So 3/2. So what we're going to do, I'll multiply this side by 3/2. I'll multiply this side by 3/2. And this is where it just becomes a little bit different. Okay? On the left-hand side, we know we chose to write 3/2 because 3 times 2 on top gives me 6, right? 2 times 3 on the bottom gives me 6. So we get 6/6 times x. Well, that's just x. Good. Okay? And this is where we just got to be careful. At this stage here, and I'll get people to grab their calculator and want to do it with their calculator, I want you to resist that urge. Don't grab your calculator. Okay? Because 99% of the time, these are pretty easy to do if you know your multiplication facts. Okay? We have a fraction times a fraction, right? Okay? And this is the idea. When I work with my calculus students, they struggle multiplying fractions. And I tell them that they are struggling with a 5th grade standard. Okay? You're to master that by the 5th grade. And they look at me like I'm insulting them. And the reason that they are not skilled at working with fractions because they were allowed to always grab their calculator when they saw one, right? And they never got good at dealing with them. If you guys take my word for it and you hold off on using your calculator and you force yourself to learn to deal with fractions for a month, you'll never want to go back to your calculator to deal with fractions because it's so much easier if you deal with them and learn the rules. So we got multiplication here, right? When you multiply two fractions, it's straight across the top, straight across the bottom, right? What's 12 times 3? 36. What's 1 times 2? 2. What's 36 divided by 2? 18. And there's our answer. Okay? 2/3 of 18. Okay, now if you were to multiply 2/3 of 18, basically break 18 up into 3 equal parts. It would be 6, 6, and 6, right? 2 of those would be 12. So 2/3 of 18 is 12. What's 12 minus 4? It's the 8 that's on the right-hand side there, right? What I want you to see there, because people will do these examples in class, we'll do these examples where it's a 1/5 or a 1/6 or a 1/3, whatever, and then in Math Excel or homework, they throw in a 2/3. It is nothing different, okay? It is absolutely 100% the same. I want to do this one. It's the same concept, but there's a little twist here. I want to make sure we understand. If I'm going to, I've been highlighting my variable term, and I want to keep my variable term where it's at. What is my variable term here?
X.
Okay, x is the variable. Well, what's the term? So it's the...
4/5 X.
Okay, it's 4/5 x, but that's still a little inaccurate. Negative 4/5. Good. Negative 4/5 x. And the reason I want to say that is that when I make a new line here, I want to make sure that that negative 4/5 doesn't disappear. Okay, and we'll talk about it when we do that first step. What would you, so if that's not going to go anywhere, we're going to leave that there. What's the first thing you're going to do? Lindsay? Subtract 5. So then I get negative 4/5 x equals 20, right? A lot of times what happens is when we do work like this and we subtract that 5, and I'm not paying attention to the 4/5 x being negative, a lot of people in the next line will write 4/5 x equals 20 instead of negative 4/5 x equals 20. Does that make sense? Okay? So now, and this is up to you, you can do this in 1 and 2 steps. Okay? Right now, you can look at this number, this coefficient, and what's its reciprocal? You kind of do that, right? Oh, that's a terrible color for you guys. Looks great on my screen. Let's go. So you went negative 5/4, flipped it that way? Okay? And that's fine. And we'll talk about the positioning of those negatives here in a moment. If I do that, then we'll come over here and go negative 5/4 as well. and this is, I like what we did here because it's a negative times a negative. What's a negative times a negative going to give me?
Positive.
A positive. And that's going to be 20 over 20, right? So it's a positive x, positive 1x. And now over here, I've got 20 times negative 5, which is negative 100, right? And 1 times 4, which is 4. So does it give me negative 25? Okay. Now, when we were looking at negative 4/5 x equals 20, if you wanted to multiply by 5/4 right away, that's fine. Okay, what's a positive 5/4 times a negative 4/5? Negative 1. Okay, and this would give me then 100 over 4. So I'd have negative x is equal to 25, right? But what are we always solving for? Positive x. Positive x. So if I want to make this a positive, what do I need to multiply by so I don't change the amount, but I change the sign?
1 over 21, 125. I don't know.
Well, think about this. So this right now says negative 1x. And I want to keep it 1x, right? But I want to make it positive. So I don't want to multiply like 2 by 2 or 3 or something like that, because that's going to make it 2x or 3x or 4x, right?
By negative 1.
Okay, so I multiply by 1 so I don't change the amount, but I multiply by a negative so that I change the sign. Does that make sense? Because a negative times a negative gives me a positive. So I multiply that by a negative, and then I'll multiply the 25 by a negative, and that will give me x equals negative 25 is what we're looking for, right? So you can do that in 2 steps. Okay, if you have a coefficient that's negative, and you don't want to deal with that until the end, you can multiply by the reciprocal, work with your signs, and at the end, if you've got a negative x left over, change its sign, and jump across to the equal sign and change that sign as well. Does that make sense? Okay. Let's see here. I think that's all we did in the last period. I'll give you, we got about 11 minutes, 12 minutes here. There's 2 assignments open. Okay, the one that's due tonight, which was yesterday's. And then I created another one. It's got about 15 questions in it, I think 14 or 15. And that's going to be due tomorrow night, but give you about 11, 12 minutes here to kind of work on that, ask me any individual questions, anything like that. Okay. If you guys have, and this, we haven't had a whole lot of time to do this so far this year where you're working in class on an assignment. If you have questions, I'd prefer that you come back to me. The mere fact that I'm kind of a bigger person, and when I'm working with somebody, if I'm working with Travis, I don't want my butt in somebody else's face. Does that make sense? I just think that's weird and awkward, and so eliminate that. Just come back to me. All right? All right. Yes.